Hello, good morning everyone. I, J. Vijay Chandra, welcomes you to WITS Connect. Today I am going to discuss regarding number system. In number system, signed and unsigned numbers. In number system, I am going to discuss regarding signed and unsigned numbers. See here, for any number before plus or minus will be there. Before it, I want to discuss regarding integer. What is an integer? The numbers are broadly classified into two. One is integer and another is real. In computer terms, real is called as float. So, integer is all positive and negative numbers including 0. All positive and negative numbers including 0. Okay, all positive negative numbers including 0 is called as integer, whereas real number is a fractional number with the decimal points. So here the number system for the integer there are two, one is signed and unsigned. That means if you are going to give any symbol before a number, it is called as signed number. And if you are going to give, not going to give any sign before it, it is called as unsigned number. Generally, the decimal numbers of positive numbers are unsigned numbers. Before the positive number, generally we won't keep any sign. We won't keep plus or minus. But in the number system, we have binary and other number systems also. So to solve this, the number systems are of, the representation is of signed and unsigned. The structure of a signed number is sign and integer, and for unsigned is just integer. That means we are going to represent an unsigned number without any sign before it, and it is an integer. And for an signed number, we are going to represent one sign and then the representation of the number, that is the integer. So there are two types of representation of this, that is fixed point representation. There are two types of representation, one is fixed point representation and another is floating point representation. Fixed point representation and another is a floating point representation. So the number system, the type of number is of two, one is the signed number and another is the unsigned number, and a integer is defined as all positive and negative numbers including 0, and whereas the real number or a float is represented as a fractional division of a number, is represented in a float, and these numbers are of fixed point representation, that is positive numbers including 0, and in fixed point representation we will have the integer, and floating point we will have the sign integer, and next is the In floating point also we have the signed floating point, unsigned floating point. So these two will be in combination with these two. That means unsigned fixed point representation, and there will be a signed floating point representation. Then comes to the fixed point representation. For the binary number representation is at one point. This fixed point representation for binary is based on some range, that is 4 bit, 8 bit, 16 bit, 32 bit, even 64 bit. Like that it goes on. The ranges of binary representation will be starts from 4 bit. Let's take an example of 4 bit. In 4 bit representation, this is the 4 bit. This is for unsigned 4 bit representation is this one. Whereas for signed, 1 bit will be meant for the MSB, which is known as most signified bit, that is MSB, and the remaining 3 bits are meant for the value, integer value or binary value. So this is unsigned for 4 bit and this is the signed for 4 bit. Then how this signed and unsigned will be represented? The sign, if the sign is 0, it is a positive number. If the sign is 0, it represents positive. If the sign is 1, it represents negative. Okay, that means minus. This is plus. If the sign is 0, it represents plus. If the sign is 1, it represents minus. Once again, I am going to discuss this thing. Number system is of signed and unsigned. That means a number with positive number is the sign will be 0, and generally the positive numbers we will not give any sign. The real numbers and integer numbers are both types of the numbers, whereas the integer number is all positive and negative numbers including 0 is the integer number, and a real number is a decimal point number. Here in terms, there are 2 types of number signs, that is positive and negative. If 0 is in between middle, the positive will be this side, and when it is down, it is a negative. Now, the representation of these numbers is fixed point representation and floating point representation. A number is an integer, that is decimal number representation, as well as binary number representation. The range of the binary number representations will be 4 bit, 8 bit, 16 bit, 32 bit and 64 bit. If the sign is 0, it is a positive. If sign is 1, it is a negative. And for a 4 bit representation, let's draw a 4 column box. The first one, this is for unsigned, and when it comes to the sign, 3 will be draw box and 1 is separate box, which is known as MSB, most significant bit. most significant bit. So this is about the representation of unsigned and signed. In combination of unsigned and signed, the fixed point representation and floating point representation we are going to discuss. Next is, what is the range of 4-bit? 4-bit representation is +7 to -7. Why it is +7 to -7? 4 bits means 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube. Okay. Here it is 1, 2, 4 and 2 to the power of 3. This is for MSB. Okay. The 4-bit representation, the 2 to the power of 3 is not for the general calculation of the number or general insertion of the number. This is for the MSB. So the value will become 4 plus 1, 4 plus 2, 6 plus 1, 7. So 7. If the MSB is plus, it will be +7. If the MSB is minus, it will be -7. So the 4-bit range is, the range of 4-bit is +7, -7. And in the same way, for the 8-bit, it will be around 125, +125 and -125 like that. This is about the range of 4-bit, and this will be an example for the 4-bit. Now, the number systems, as I said, it is signed, unsigned, fixed point representation and floating point representation. You should know the word known as Mantissa. What is Mantissa? A single fixed point number is called as Mantissa. That means the floating point number is divided into 2 parts. One is Mantissa and another is exponent. So these two important terms here, one is Mantissa and another is exponent. The representation, how it will be, I will show you. Structure of numbers. The structure of numbers is, one is integer, where you are going to declare this is the fixed point. It is unsigned. It may be a negative or positive. Since it's an integer, it's an unsigned. It's a part of fixed point representation. Then comes to the second one. It is a sine, and next is integer. This is meant for fixed point signed representation. So next is the floating point representation. The floating point representation consists of Mantissa as well as the exponent. So here this is a sine, exponent, and next is sine and Mantissa. So the floating point representation is of 2 parts. One part is with exponent and sine, and the other part is with Mantissa and sine. For example, we are going to check the floating point, that is Mantissa as well as the sine. How it is represented? It is represented in m into r to the power of e. M into r to the power of e, that is the floating point. So let's take an example. Representation of number 378.53. This is a positive number, unsigned, and it will be represented in the form of 37853 into 10 to the power of minus 2. That means the point is removed from here and multiplied with 10. That means if I remove this number 37853 by 100, I can give. This I can change into 37853 into 10 to the power of minus 2. 10 to the power of minus 2 is nothing but 1 by 100. So like this we can change. Next example, for the floating point in a binary stage plus 1001.11. Here it's 8 bit and 6 bit. 6 bit is for the exponential. For the exponential sake I am using the 6 bit. So this is for the fraction. So this can be represented as 1, 8 bit no 0. So one thing, 8 bit means 1 column, 2 column, 3 column, 4 column, 5 column, 6, 7, 8. 8 bit. Okay. And next is 6 bit. 1, 2, 3, 4, 5, 6. In this 8 bit column, I have to represent. So I will start from here 1, 1, 1, 0, 0, 1. So what I have to do is I will draw here again 0, 1, 0, 0, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8 bit is 0. And now 6th bit representation. 1, 0, 0, 0, 0, 0. So this is calculation of floating point representation and fixed point representation. In next session, I am going to discuss regarding conversion of octal and hexadecimal with the decimal numbers, binary addition and binary subtraction, BCD and gray code. Thank you very much.